Here we'll examine the domain and range of a rational graph, which is of the form y equals 1 over x. We can see on this graph that there appear to be a couple of walls that this function won't pass. It looks like this function starts out on the left side running close to the axis. It looks like it's going to continue toward the right, but at around x equals 0, it suddenly turns downward and runs off at the bottom toward infinity, symbolized by the down arrow that we see in this position. Then it suddenly reemerges on the other side of that wall toward positive infinity, and then starts decreasing and runs along the x-axis again. I'll draw the wall that the function refuses to pass through in orange now. Since this line that I've drawn is vertical, we will call this a vertical asymptote. Now we can see this vertical asymptote runs directly along the y-axis, and the y-axis is where x equals 0. Now, since that is the place the function cannot go, we will specify for our domain that x can't be 0. However, notice that we do have a left arrow and a right arrow on this graph. The left arrow symbolizes negative infinity, and the right arrow symbolizes positive infinity. Based on this, let's try to draw a number line to symbolize our domain. We would start at negative infinity, run all the way to positive infinity, but at 0 we have a gap in our domain because the function cannot reach x equals 0. We'll symbolize that with a dotted line. That dotted line will split our domain into two pieces, which I label piece A and piece B. Piece A will go from negative infinity, but stop at 0. And then piece B will start at 0, and then go toward positive infinity. For piece A of our domain, we'll say negative infinity to 0, and then for piece B, we will say 0 to infinity. Now, in between these two pieces, we'll write the letter U, which stands for union. Union means that you have two pieces in your domain or range. Also, if your domain or range contains an asymptote, we will use parentheses and not square brackets to show that the function will not include those values. For that reason, we'll say parentheses around negative infinity to 0 for piece A, and another parentheses around 0 to infinity for piece B. And this will be our domain. Now let's examine our range. At the bottom of the graph, we do see a down arrow, which represents negative infinity. At the top of the function, we also see an up arrow, which represents positive infinity. However, we have another asymptote, which I'm drawing in green now. This asymptote is horizontal, on top of the x-axis. And the x-axis is the place where y equals 0, and since this involves y, this will restrict our range. That asymptote makes it to where y cannot be 0. Once again, we'll draw a number line. This time, we'll use an up arrow and a down arrow for our range. We'll say negative infinity at the bottom, positive infinity at the top, and then a horizontal asymptote at 0. So our range is also split into two pieces. Piece A at the bottom, piece B at the top, because we always read the range bottom to top. So piece A also goes from negative infinity to 0. We'll also use parentheses because of that asymptote. That means that 0 is not included in our range because we never reach it. Piece B will go from 0 to infinity, starting at 0, going to infinity. So it turns out our range is just the same as our domain because all of our asymptotes are at 0. So for both domain and range, make a note of your asymptotes and create a split in your domain or range based on those locations. The domain is affected by vertical asymptotes, and the range is affected by horizontal asymptotes. Now let's try to find f at 1. Notice that 1 is not marked on this graph, but instead we can go halfway between 0 and 2. That will be this position, which I'll mark with a 1. Let's find where the graph is located on the axis and draw an orange dot there and try to read the y value. Notice that is also halfway between 0 and 2, which will give us a y value of positive 1. Now, if we try to find f at 0, however, I'll circle that in blue, and you notice that we are directly on the asymptote if we try to look for f0. If we are directly on the asymptote, the function does not exist at that position because that is the place where the graph can't go. Therefore, anytime they ask you for an x value that happens to be on an asymptote, we will give the answer does not exist or D and E. And so this is how we analyze domain and range on a rational graph.